Let's continue with the coin caliper project by inserting the Vision Assistant script that was developed earlier as the Vision Assistant Express VI, and we'll place that for inline processing in the while loop that we just developed. I'm back in the block diagram, and I'll place the Vision Assistant Express VI. Very first step, go to File, Open Script, and open up the coin diameter script that was created in an earlier step. Check to see how we're doing. I'll select the max clamp step. That seems to work properly. We see the start and end points properly displayed. I'm acquiring my image data as grayscale. That means I can remove this step that extracts the luminance plane. I'm going to do a quick look at the performance meter. It says that the average time for processing is 6 milliseconds. Here you can see a detailed breakdown for each step. This performance meter is also available in the standalone version of Vision Assistant. It's a nice way to kind of get a sense of which steps might be taking too much time. Now you can select controls and indicators for each one of the steps in your script. I need the clamp results at the end, and that should do it. I'm also going to create a destination image, and let's move on and hit finish. And at this point I'm seeing a little bit of a error message showing up. Basically, LabVIEW is attempting to store the calibration image on MyRio. However, it's not required for point distance calibration, and this particular error message can be safely ignored. Let's open up a little bit more room and move the Express VI inside the while loop. I'm going to disconnect the image indicator and reconnect it on the output of the Vision Assistant Express VI. That has the advantage that allows you to see the overlay generated by the max clamp step. I'll create an indicator for the results of max clamp and then place that underneath frame rate. The one of particular interest is the distance in real-world units. Let's go ahead and run and see how we're doing. And it looks like we're getting around 23 millimeters for the €1 coin. I'll show you how you can extract only that single value. I'll do unbundle, doing unbundle by name, and then create a single indicator for the output of that unbundle. And this is going to be my diameter of the coin in units of millimeters. Now at the moment I'm picking distance in pixels. I want distance in real-world units. And again, that's millimeters based on the way that the camera calibration was set up. I'll just go ahead and delete that larger display and rerun, see how we're doing now. All right, this looks pretty good. Let me try moving the coin around a little bit. And you'll notice that when the coin moves out of the region of interest, measurements cease, and we just see 0 showing up for the measured distance. Try pushing that back into the region of interest. Now you might observe the measured diameter for some different coins. Looks like about 23.5 millimeters for the quarter. Let's try the 50 pence piece. And from edge to edge, coming in at 27.2 millimeters. All right, this is working well.